Hey everybody, we're going to be looking at 3.1 today. We're going to start looking at what we call polynomial functions. A polynomial function is like these linear and quadratic functions that we've been doing, but they're up to higher degrees. For example, a linear function is of degree 1 and a quadratic function is of degree 2. Okay, cubics are of degree 3. They're also polynomials. So polynomial just means many, right? Poly many. So we can go 3, 4, 5, all the way up as high as we want. Okay, now today we're mostly going to be looking at 3s and 4s, which we call cubics and quartics, but these ideas extend to all polynomial functions. Now, typically, even functions, which we'll look at later, have special rules, and odd functions have special rules. But we won't look at that today. We're just going to look at things like end behavior, where zeros are today. Okay, so starting out, we need to be able to evaluate a function at a point. And we did this a little bit in the last unit. Okay, but I'm just going to take -2, I'm going to plug it in. Now, it is important when you do this that you put parentheses around every place you have an x, especially if you have negatives, especially if you're doing squares and cubes and such like that. The reason is if you don't do that, your calculator may do it in the wrong order. Okay, so again, I don't mind if you use a calculator to throw this in and get an answer. Okay, I'm going to do the arithmetic. The idea is, again, I'm not testing you on arithmetic. My hope is that you did that in 3rd and 4th grade and were tested there. I'm testing you on the skills that we use with that arithmetic. So -14 minus 6 will be -20. Excuse me. So then we're going to take 6, we're going to plug it in. So again, make sure we're putting parentheses. Plus 3, 36, plus 3, 39. Okay. So what I want to look at today is what are these characteristics of cubics? What are these characteristics of quartics? Now remember, a cubic is anything with x to the third, where the 3 is the highest power. I can have other things, and that's fine. My highest power is what determines it being what it is, in this case a cubic, because it's 3. A quartic then would be 4. And I'm just making up random ones right now. Okay, and I don't necessarily need to have all the pieces. I'm missing an x squared here, right? Really 0x squared. I don't need all those pieces, okay, for it to still be a quartic. It's a quartic because the highest power is 4, okay? This is not a cubic because even though it does have a third power, my highest power is 4, okay? And what we notice on cubes or cubics is that they have this pattern that looks like this. Kind of looks like similar to a linear, but it's more curvy. Okay, it could also look like this. Okay, a quartic can look like something like this, which I know looks like a quadratic. We'll get into that a little bit later, why maybe this one isn't. Okay, and it also may look something like this. Okay, again, the thing with quartics and quadratics is sometimes we do see some similarities between them, especially if we don't have all these extra terms. These extra terms typically add more bumps. If we just had this first term, and that was it, that's when it's going to look very similar to a quadratic. The biggest difference being is how fast it goes up. And the reason for that is, if I take x squared and x to the 4th, and I plug in 2, this is going to be 4, and then this would be 16. Okay, so it's going up much quicker. So a quadratic may look like this, whereas a quartic would go up significantly faster. Excuse me. Okay, so looking at these, let's go through a couple of these real quick. I want to start with the ones that don't have any extra stuff. Okay, because those are the ones that, again, those are those parent functions that we talked about in the last unit. So the parent function of x cubed is going to be right here. Okay, it doesn't do anything fancy, it just goes through the middle. Okay, it's a little curvier than a linear. Okay, and then like I was showing you on the last one, this would be my parent function of x to the 4th. Okay, what that does is that gets rid of two of them. Okay, I still have a quartic here on C. I still have a quartic on big B. Okay, I still have two quartics here and here. Well, if we notice, right, negative, positive, positive should be facing up probably like the quadratics. So then this F term is probably here. And then C is probably here. Okay, thinking the same idea with like a linear function, right? This is my parent function, and this is the way it goes when it's positive, positive, negative, then this one is probably A, and this one is probably B because it's going in a different direction. It's going down, up, down instead of up, down, up. Okay, and let's look at this. Okay, so we look back at those ones and we see that a lot of these intercepts are the same. Okay, this one has intercepts at -1, 0, 1. This one has intercepts at -1, 1. So this one had 3 intercepts. This one has 2. This one has 3x intercepts, but instead of going, if you notice at the 0 here, instead of going through, it kind of just touches it, and that's going to be important later. Okay, so this one has 3. This one has 3 as well. Okay, this one looks like it may have more than 1 because of kind of where it is in the middle there, but it's actually only 1. And then same thing here. This is only going to touch 1 time. Okay, so let's look at the cubes for a second. The cubes, we have 3, 3, 1. The squares, we have 2, 3, 1. Okay, that's going to be important in a second when we start talking about what we call multiplicity and how many zeros a function can have. Okay, so first we need to decide, okay, what is a polynomial? Like what makes a polynomial a polynomial? And the answer is basically it has exponents. They're not negative. They're not fractions. We don't have any square roots or sines or cosines or tangents or anything like that. We just have x to a number that's positive. Okay, so looking at this first one, that's a polynomial. I have x to the third, x to the really 1, and then a constant. This next one is meant to try to trick you because you have a decimal here and a square root here, but the coefficients here don't matter. The coefficients can be anything they want to be. It's the exponents that matter. I have a 3 here. I have a 4 here. Now, they're not in the right order, and we'll talk about order in a second, but this one's fine. This is a polynomial. There's no negatives. There's no square roots on the variables. This one, okay, 2. Now I have a problem. Because this is a negative, this is no longer a polynomial. Okay, and then here, 2, 1. Okay, so if so, got a polynomial. If so, write it in standard form. Okay, standard form, all standard form says is that the numbers on the exponents need to go down. So for example, on this first one, 3, now I don't have a 2, and that's fine. 1, and then technically 0. This one's good. Second one though, 3, 4. My numbers are not in the correct order here. So I need to put them in the correct order. And when I do that, I want to make sure that I keep all the stuff together. So all this stays together, and that minus or that negative is important. So square root of 2, x to the 4th, minus 0.8, x cubed. Okay, now we don't have an x squared term, so we don't need to worry about that. We don't have an x term, don't need to worry about that. Minus 12. Okay, so now we're in the right order. This one again, 2, 1, standard form, done. Okay, degree. My degree is just the largest exponent. So for my degree here would be 3. My degree on this one is 4. It's not 3. You need to put it in standard form first. So my degree here is 4. My degree here is 2. Type. This one is a cubic. This one is a quartic. And this one is a quadratic. Leading coefficient, so I go to that front one in standard form and just write down the coefficient. So my leading coefficient here is -2. Leading coefficient on the second one, -0.8 or 0.8. And then my leading coefficient here, I have that invisible 1. Okay, so now that we know what these look like in the order, we can actually start playing with them a little bit. Okay, now today there's going to be a lot of, or not a lot, a little bit of hand waving as to how these things are formed. We're going to use a lot of technology today. So if you don't already have Desmos up, go ahead and take a second, pause the video, get Desmos up. You're going to need it today. Okay, and the reason is because it's going to save you a ton of time. Okay, so my first step here is I want to take this and put it in Desmos. Let Desmos do the work for you today. Okay, once we start getting into it a little bit more and you start understanding it more, I will start asking you to create these by yourselves. But for now, let's use Desmos. Let's use it as a tool. Let's get where we need to go. Okay, so starting out with Desmos, we're going to go to that graphing calculator. I'm going to type in the equation, so 2x to the 4th. I think I can copy this. Let me just try that real quick. Perfect. Nope, didn't quite do what I wanted, but that's an easy fix. 2x to the 4th, and then x squared. Okay, so this is what my function looks like. Now, if you notice, it's got a couple of important critical values, like we talked about before. We've got x-intercepts, we've got a turning point is what we call those. They're kind of like vertices, but typically we think of vertices only on quadratics. We've got a y-intercept, we've got another turning point, and another turning point. Okay, but this question says, well, what is it at 3? Okay, now you got two choices. You can sit here and try to find 3 and then, run along it and go, oh man, I gotta move it and do all that stuff. Or, remember from last time, we can just create a table. So 3 is at 98. Again, not testing you on your arithmetic skills. You could take 3, plug it in here, okay, and then solve this out. That's fine. Or we use Desmos, let it do the work for us. It's going to be 98. Okay. Now, one of the big things I do want you to be able to do in this unit, in this section, is to be able to graph the end behavior of these functions. Okay. Now, really what it's going to come down to is your degree odd or even? Okay. If it's odd, actually, let's talk about even first. Even's a little bit easier to see. So when I think about a quadratic, the degree is 2 because the biggest coefficient is, exponent is 2. When it's positive, it looks like this. And when it's negative, it goes down. That is going to be true for every single even function, or even polynomial, I should say. Okay, so for every single even polynomial, positive up, negative down. For odds follow the same pattern as a linear. So think about when you do a linear function, it looks like this. When it's positive, it starts at negative infinity and it goes up to positive infinity. Okay, now with higher degrees, it may do funky stuff in the middle, but at the ends, it's always going to come from negative infinity and go to positive infinity. Now, if that leading coefficient is negative, though, it's going to go the other way, just like a linear would. Okay, it's going to start at infinity and it's going to go down to negative infinity. Okay, so what I usually like to tell students is, okay, don't necessarily consider, that it's a 5th power or a 7th power or a 20th power. Think about, is it odd or even? And then go back to the idea of, is it a linear like these top ones, or is it a quadratic? Which way do those face? Okay, so